Okay, so here we're going to solve quadratic equations using our square root property. So basically what the square root property is that if we have a real number that something squared is equal to, then when we take the square root of both sides, if the radical was not already there and we introduce the radical, it becomes plus or minus. And we can also use it if our equations look like ax plus b quantity squared. So that means that we're going to have plus or minus answers for this. Alrighty, so let's look at our first example. So x squared is equal to 9. I'm going to show you two ways you can solve this same equation and get the same answer. So if I subtract 9 from both sides, I get x squared minus 9 is equal to 0. Now this we know as the difference of squares. We've learned this before, so we know it's going to be a minus and a plus equal to 0. Square root of x squared is x. Square root of 9 is 3. So we can get it solved this way. Take each part, set it equal to 0, add our 3 over, and we get x equal to 3. Subtract the 3 over, and we get x equal to negative 3. Now the new way that we can solve this problem using the square root property is I have something squared equal to a number. I can take the square root of both sides. Well, the square root of x squared will be x. What I have to do is when I introduce the radical into the problem where it wasn't already there, I have to do the plus or minus, and I get the square root of 9. Square root of 9 is 3, so I get plus or minus 3. So here I have plus or minus 3. I get the same answers. It's a little less work. But understand, those are the same answers. So you could do it either way. And this worked because we're taking, this was easier because it's a perfect square. Let's go do one that's not. So if we have this x squared is equal to 50, we are going to take the square root of both sides and get x is equal to plus or minus the square root of 50. Now we're going to have to break down that 50, what we've learned in other lessons. So two factors. Again, it doesn't matter which you pick. You can pick 2 times 25 or you can do 5 times 10. It doesn't matter. 10 is going to be 2 times 5. So I end up with the square root of 2 times 5 times 5. We're going to take a group of 2 because we have an index of 2 on our square root. Pull that out. We end up with 5 square roots of 2. So x is equal to plus or minus 5 square roots of 2. And that would be our answer. Now we can check this. You can put it into your original equation. We can do a check and put in our 5 square roots of 2 and square it. Is it equal to 50? Now, it wouldn't matter if we put in the positive or the negative because we're going to square it. And anytime we square a number, it's going to be positive. So we can put the negative in there just because, like, what if it was negative? Well, a negative times a negative is still going to get us a positive. 5 squared will get us 25. And the square root of the square, or squaring the square root, so let's put that over here. If I square a square root, and I'll put the 2 in there just so you know that's what I'm just pulling that part over. The squaring takes care of the square root. So you'll just be left with the 2. So it'll be 25 times 2, which will be equal to 50. And 25 times 2 is 50 equals 50. So it checks. And you can do that on all of them. I'm not going to, but you could. All right, next question. We have x squared is equal to 32. So square root of both sides. X is equal to plus or minus the square root of 32. Again, not a perfect square. So I'm going to bring it over here and break it down. 32 is 4 times 8 or 2 times 16. It doesn't matter. 4 would be 2 times 2. 8 will be 2 times 4. and 4 is 2 times 2. So we end up with 1, 2, 3, 4, 5 2's. Underneath our radical, we're looking for groups of 2 because we're doing a square root. So 1 group, 2 groups. So 2 of a kind. Doesn't have to be a 2, it just has to be 2 of the same. So we end up with 2 times 2, so 2 times 2, square root of 2. That 2 times 2 is equal to 4 square roots of 2. Anything you pull out, you're multiplying. So now we bring it back over, and we have plus or minus 4 square roots of 2. All right, so let's look at some equations that are a little bit different looking. So if we have 2x squared minus 14 is equal to 0. Here we don't have anything on the other side, and we don't have a perfect square sitting there. So what we're going to do is add the 14 over and get 2x squared is equal to 14, divide by the 2, and get x squared equal to 7. Now that we have the x squared, we can take the square root property and get x is equal to plus or minus the square root of 7. Square root of 7 isn't going to break down. That's all it's going to be. So we will just have to leave it as it is. Let's do a similar problem. If we have 5x squared minus 50 is equal to 0. We're going to add the 50 over and get 5x squared is equal to 50. Again, divide by 5, and x squared is equal to 10. As we do the square root, we'll have x is equal to plus or minus that square root of 10. If we bring the square root of 10 over here and try and break it down, we only get 2 times 5. We can't get a group of 2 of the same numbers, so we'll just leave it as plus or minus the square root of 10. All right, let's look at another problem. If we have the not the square root yet, sorry. I'm looking at my examples. So I'll go down just a little further. If we have x plus 1 squared is equal to 12. So with that, I'm going to take the square root of both sides. Just like before, the 2 took care of the squaring on that one of the early problems where we were checking it. Square rooting a square, those cancel each other out. So we end up with x plus 1. Here we have to do plus or minus that square root of 12. Again, we got to break down the square root of 12. So 2 times 6, 2 times 3. We get square root of 2 times 2 times 3. Looking for 2 of the same number, we end up with 2 square roots of 3. So x plus 1 is equal to plus or minus 2 square roots of 3. We're going to subtract 1 from both sides and get x is equal to negative 1 plus or minus 2 square roots of 3. You cannot combine that negative 1 with the 2 because this is like if it had an x on it. This does not, so you can't combine them. This would be your final answer. So do be careful about that when you bring them over and you already have some numbers. All right, what if we have x plus 3 squared is equal to 20? Again, we're going to take the square root of both sides. The square root of something squared, it will cancel. We end up with the x plus 3, plus or minus the square root of 20. Square root of 20, we're going to break it down. 2 times 10, 2 times 5. So we end up with the square root of 2 times 2 times 5. We have 2 that are the same that come out. So it equals 2 square roots of 5. So this will be plus or minus 2 square roots of 5. Now to get my x by itself, I'm going to move the 3 over, and I get x is equal to negative 3 plus or minus 2 square roots of 5. So these are ending up looking like something we'll see in a little bit when we move into quadratic formulas. All right, let's look at the next problem. We have 2x minus 5 squared is equal to negative 16. So we're going to take the square root of both sides, and we end up with 2x minus 5, because again, it will cancel that squaring. is equal to, now with that plus or minus, that square root of negative 16. We have to take care of the negative. We've learned before in a previous lesson that means we're going to take an I out. So 2x minus 5 is equal to plus or minus I square root of 16. The square root of 16 is 4, so 2x minus 5 is equal to plus or minus 4i. We will add the 5 over and get 2x is equal to 5 plus or minus 4i. Again, they can't combine because that I, this doesn't have an I, so it has to stay separated. And then we'll divide by 2. So x will be equal to 5 plus or minus 4i over 2. And that would be our answer. All right, let's do a similar problem. So if we have 5x minus 2 squared is equal to negative 9. Again, we're going to take the square root of both sides and get 5x minus 2 is equal to plus or minus the square root of negative 9. So 5x minus 2 is equal to, again, we have to take the negative out by putting an I. Remember, I is equal to the square root of negative 1. So then we have I times the square root of 9. So 5x minus 2 is equal to plus or minus. Square root of 9 is 3, so 3i. We'll add the 2 over and get 5x is equal to 2 plus or minus 3i. Now we'll divide by 5 on both sides, and x is equal to 2 plus or minus 3i all over 5. And that would be our final answer.